Hello, good afternoon, good morning, and welcome back to Next Gen Road Fuels virtual workshop on hydrothermal liquefaction in the green energy transition. My name is Chiara Benetti, and I welcome you on behalf of ETA Florence Renewable Energies organizer, technical organizer of this event and project partner of Next Gen Road Fuels. This session, entitled Technology Scale Up and Market Uptake, bringing together technology providers and end users, will last until 5:30. We will have 3 Q&A sessions. You can participate in the session by typing your questions in the Q&A tab that you can find at the bottom of your screen. You can type your questions throughout the webinar, and our panelists will have the possibility to reply to your questions by typing the answers directly in the Q&A tab or by answering live. Please do use the Q&A tab for questions and not the chat box. This webinar as well will be recorded, and you will find the recording and the presentations tomorrow on Next Gen Road Fuels project. And that's all from our side. Now I leave the floor to the moderator, Mr. Lasse Rosendahl, Head of Department of Energy Technology from Aalborg University. And thank you, and enjoy the webinar.
Thank you very much, Chiara, for introducing me. It's a pleasure to moderate this second session of the workshop. We ended the first session on a question of whether HTL would play a role also in 2030. And I think that is a very good lead-in question to the focus of our second session, the technology scale-up and market uptake, where we shift perspective a little bit and try to look at it from this commercialization and end-user perspective. And it's so the session is in 2 parts. We will start by having some presentations from some of the leading developers, end users, and commercializers. And then the second half, we'll have a panel debate moderated by Dina Barkowski from the Bioenergy and Sustainable Technologies Organization to take us towards the end of our second session. But without further ado, and not to steal much more time, let me introduce our first speaker in the session, Mr. Mikhail Christensen, Senior Vice President of Steeper Energy.
Thanks, Lasse. I'll share my screen here. I think it's... All right. So we see my full screen now?
Yes.
Yeah. Okay. Thank you very much for this opportunity to present the Steeper Energy approach to the market opportunities. I have chosen to take a slightly different approach, trying to focus on some of the challenges that you are facing when you're actually trying to commercialize your product or your technology. Steeper Energy has been working in this space for the last 10 years, and we are actually very close to getting into the market with our technology. Doing that actually means that we are facing some challenges that I would like to share with you. And why is this not responding to me?
Black arrow in the left bottom part of the screen.
Oh, sure, yeah. How do we actually approach this? Well, what we are doing is really looking at this from what we call a change management perspective. We are actually entering a market where you know, everything we do will actually increase risk and challenge to existing technologies. So we have actually realized that we need to fully understand what the value network that we are entering into looks like. we need to appreciate and address all the concerns that exist with these stakeholders in the existing network. And the change that we actually need to participate in actually starts with actually realizing this and answering the questions. So we actually have realized that demonstration plants will reduce technical concerns and also by that financial concerns, because when it comes to the end, a lot of this concern really comes back to financial concerns and risk mitigation. So doing that actually means that we need to demonstrate that the entire value chain from feedstock to final finished fuel is actually a viable construction. And doing that actually means that the transfer from the existing value chain into the new value chain will actually be meaningful and viable. So in doing that, it is in our view critical that we actually are able to engage a critical mass of stakeholders to drive this change. So what are we actually doing in that context? Well, we have already demonstrated that we can actually make an efficient production of biocrude. We can and have already presented a full characterization of oil from woody biomass and from urban waste streams. Yes, we are on the way to do that and expect that to happen very soon. On top of that, and that's quite critical to handling those questions and risks that actually remain in the market, and that is the downstream handling of the biocrude. And we have actually demonstrated pathways for standalone upgrading and also for co-refining with fossil counterparts. So I'll say a few words about that. So the the hydrothermal biocrude is actually quite similar to the fossil counterpart, but also different. So it's not immediately measurable with the fossil part, but we have actually shown pathways that actually makes it possible, and that's quite critical to actually de-risk the entire value chain. And of course, in doing that, we have demonstrated that the fossil fuel standalone or in co-refining is upgradable to diesel, marine, and jet fuel. One of the activities that we're actually undertaking right now is establishing the STIBA, what we call the STIBA Advanced Biofuel Center, and that is really a full, mini refinery. We have the capacity, ability to actually, take our own biocrude and actually upgrade that to finished fuel in this center. So doing that actually means that we will be able to actually further develop and further de-risk the value chain that we are facing and entering into. And talking about the commercialization and demonstration of the viability, we are, as many may know, already engaged in finalizing a demonstration plant with our partners in Norway, Silver Green Fuels, which is based on Statkraft and Södra. And this demonstration plant actually expects to be running later this year. Q3 is the expectation. And the successful demonstration actually will lead to, is expected to lead to a decision to actually make full-scale plants after that. So this is just a summary of what has just been said, so I won't repeat that. But just in short, the challenge that we are facing simply means that there is a need for us to actually demonstrate and de-risk a lot of the value chain, or if not the entire value chain, but in particular the downstream part of it is critical, and that is actually has been done in lab scale, and now we are doing it in a continuous mode scale. So this was my presentation. Thanks for your attention.
Thanks a lot, Mikhail. I've been looking. So please write your questions in the Q&A, and we'll drop them. I just have a quick question for you, Mikhail. As also, Stephen Gust was asking about scale for the next, and you talk about the Advanced Biofuel Center and the scale. So when you talk about de-risking and what kind of scale are you looking at to be appropriate for this?
For the upgrading and for the we are looking at in terms of capacity, what is probably producing less than 10 liters per day.
Okay.
Yeah.
All right.
Yeah.
Okay. Thank you very much. If you have questions for Mikhail, then please put them in the Q&A. And meanwhile, we'll turn to our next presenter in this first part of the session. John Halliday from the Pacific Northwest National Lab. So John, I hand over to you.
All right, thank you very much. I appreciate this opportunity. Let me see. I believe the incorrect screen is being shown. Is that right?
See the, I don't know if you hit F5, maybe it'll go into the presentation mode or something.
All right. Do you see the presentation mode now?
Yeah.
Yeah.
All right. Good. Excellent. Thank you. As I said, thank you very much for this opportunity. Recently, PNNL hosted a similar workshop series as this one. Our focus was on aviation fuel, and what I'd like to do is just walk through some of the things that was presented there, as I think it helps with providing this perspective of some of the demonstrations. I'm certainly not hitting every demonstration, so I apologize to those that are listening if I don't hit your particular demonstration. At the conclusion of this, I will pull out some of the specific challenges that have been identified and that we are preparing currently in a report. So let me begin. We heard from both developers and people who are thinking of using this technology. We had a very wonderful talk from Metro Vancouver, and some of the key things that they pointed out as needing as we go forward is, answering the two basic questions. And one of those is, can hydrothermal liquefaction perform better than anaerobic digestion? That is one of those things that they are seeking to identify and answer in their own demonstration facility, which you can see here in this little green box on their footprint. The other question is understanding the economics at full scale. So there are certainly several science needs, and these science needs really continue to focus on what are we doing with the aqueous stream. And at PNNL, we agree that this is one of those critical science needs. From a wastewater facility, they could put it back in their headworks. They could do anaerobic digestion. So there are other things. And this will be one of the common themes that we'll talk about throughout the presentation. There's also within that aqueous stream, the ammonia, the phenols, and other things, what will need to be done to really remove those. Ultimately, we're really talking about water management, and that's critical. The other part is really thinking about getting more value. So can we recover appropriately the phosphorus and other things? And also in that value chain, is this a technology that can effectively remove compounds of environmental concerns? And in our work at P&L, we see the destruction of these types of compounds, and that's part of that value chain that we need to better understand. Going on, goodness. Steeper Energy, who we just heard, gave a very nice talk and about both their efforts in Norway and Calgary. And a lot of what they pointed out to was the need for hydrogen and those links to the refining, and we just heard about that. So utilizing the in situ renewable hydrogen for cost-effective upgrading is one of those things that we think is an important thing that we better understand. We heard about the evaluation of the integration of biocrude into existing refineries, and also understanding the use of upgrading that biocrude outside. I'll work on that some more, or talk about that further in just a few moments. But it's developing that economic pathway to, in their case, looking at least what they spoke about was 100% renewable gasoline, diesel, jet fuel, marine fuel, and so forth. And we certainly agree with what we just heard, that HTL is particularly valuable because it can go into the fuels that are needed for heavy duty use. In Australia, we have the northern and southern oil refineries, and David Lewis spoke about this. Again, it's can we not only get a return on our investment, but will we even get our investment out? And there remains a lot of concerns on the cost, both the capital cost and the operating cost. And can this be done without the need of a tipping fee, or is that tipping fee going to be required? So a general concern is identifying those major cost drivers and pulling those out. As we have time, I'll also mention a little bit more of that. In Licella, which practices a catalytic form of hydrothermal liquefaction, is looking at additional feedstocks that I think many of us are interested in, end-of-life plastics, as well as the post-consumer biomass. And again, one of the common themes that I think all of us are thinking about is access to large amounts of low-value feedstocks without creating the bidding wars. As the feedstock cost goes up, that's such a huge cost driver, we no longer can afford, or the cost of the fuel becomes too high. The other thing that they pointed out is the need for the development of us, each of us doing what we do best. So we need to have more alliances. Operational companies require a very different mindset than a technology different development company. So those are some of those key things that Licella brought out. Reliance also working on this in India, point out the need to demonstrate the robustness at scale to reduce the risk. So we don't have enough information at scale, both time, on scale, and demonstrating some of the challenges. And this is going to be critical for that roadmap of the economical viability to continue to reduce that risk. Of course, now in Europe, some of the, now to a pilot scale work, David Chiaramonti spoke about the co-liquefaction of a feedstock, and at P&L, we certainly agree that this is critical, that most likely we will not have a single feedstock, but we will have mixtures of feedstocks. And again, the water management issues is something that really needs to continue to be addressed, whether we're looking at some sort of catalytic hydrothermal gasification or anaerobic digestion of hydrogen production. There are challenges. And on the catalyst side, there are real challenges with sulfur and other poisonings that I think they're recognizing, and P&L also is facing. We also are looking at stabilization of these materials. So let me just go on, because I do need to finish, but also in Europe, some of the very nice work in the high flex fuel consortium. Taking a look and understanding the spatial analysis of residues in Europe and understanding that feedstock density, looking at maps of where we're going to get enough feedstock to be able to do this, in addition to the nutrient recovery that others have talked about, and getting value out of each of the streams that are coming out of the HTL, including the aqueous stream. Okay, so that kind of gives a summary of what people were speaking about, but P&L also we're more of a pilot than a demonstration kind of stage, but the capital cost does need to come down, and 50% of the capital cost, at least as we're looking at things, come in heat exchangers. So there's a huge opportunity to understand that and reduce the capital there. And we have found a tremendous reduction of cost as we look at reducing some of these big capital intensive areas, with heat exchange being one of those. The feedstock is critical. We highly feel that we need to be able to think about blends. For us, we look at two different kinds of blends. One of those is an urban waste blend, which includes food and sludge, as well as fats, oils, and greases, and a rural blend that would have manures, food, sludge, and fats, oils, and greases. These are targeted based on what's available in these regions in a 50-mile radius. Upgrading and improving the catalyst life becomes really important. I am super excited to share that we've just completed a 2,000-hour catalytic upgrading of untreated biocrude into diesel fuel and other fuels. And achieving that 2,000-hour mark without seeing any catalyst degradation was really, really important as we want to be able to reduce that risk. And being able to do this with an untreated biocrude largely as received out of the HTL reactor is super important. And this does require that we really are able to effectively remove both iron and other metals and minerals that are in that biocrude. The gasification of the water phase is much more difficult. The sulfur continues to be a poison there. And so thank you for your time. I do have a conclusion slide, and let me just share that real quick. So, as we look about this, we think about the feedstocks, the intermediates, the final products, and really understanding the sustainability. And there are major gaps in each of these that we're addressing, and I think others are addressing. And for this to become commercial, we really need to continue to understand those major gaps and close them. So with that, thank you for your time.
Thanks a lot, John. No, very interesting. And let me just start by congratulating you on the 2,000 hours. That is an achievement indeed. So we have a bit of time for Q&A. I think that there aren't any open questions in the Q&A session. So, but if you have any, then please indicate so. We'll take them live. While you think about good questions, let me just ask you, John, if you can elaborate a bit on the biocrude. You said it was untreated biocrude. Which of the was it one of those two blends you were mentioning?
Thank you for the question. Yeah, sorry I didn't talk about that. So we actually used, for us, and running for 2,000 hours requires that we have a tremendous amount of biocrude.
Exactly.
We used everything.
Oh,
so
right.
this included, we started with sludge out of some work that we did. The sludge came to us from a Detroit water facility, the city of Detroit, and that sludge was untreated in the HTL. And we do some simple things to remove some of the minerals and so forth before the upgrading. It moved into food waste. That food waste came from prisons. It came from military sources. It came from universities. It had some wood in there. It had some algae in there. So we just we're just going through all these things. At the conclusion of the 2,000 hours, we started then really pushing some of the conditions. We were largely running at a space velocity of about 0.5, which is good. We'd like to be at 1, and you can begin to push that, but it was a a single bed, but we do have, in order to, I think, iron, etc.
Right.
So that becomes a real issue, right? And iron. And in some of the feedstocks, the iron comes in different forms. There are some feedstocks that have some porphyrin compounds that are really challenging to use. But in this case, it was a guard bed. So in the past, we have done some pre-treatment of the oils in order to remove some of the iron and other metals. So doing a demineralization. But in this particular case, over that 2,000 hours, it was effective use of different guard beds.
Very nice. Thank you. And you saw the question from Ib Johansen on the iron that I noticed or not. So, but I guess you answered that. So that was great.
Yeah. Yeah, I see another question on the separation of the aqueous phase from the biocrude, and thank you for that one as well. If in the as you run the HTL process, if you do an effective job of removing the solids and the water, then we can get a phase separation, and that's what we do in continuous reactors that are done at a bench scale. We do the phase separation in a bench operation, but in this run we did that water biocrude separation in a continuous separator, and it actually worked better than what we see in the bench scale. So the nice thing at this in our HTL at the larger scale, we do see very effective water or aqueous and biocrude separations, as long as we can effectively remove the solids.
That's very, very. This is a key thing, and I think a very interesting approach. So, yeah, very interesting. Any further, not only to John, although of course technology is extremely exciting. Here's another question on comparing HTL to AD.
Yeah, I'd be happy to give my thoughts, and maybe others would as well. In the United States, anaerobic digestion is incredibly interesting because the methane in renewable natural gas is incredibly valuable, and that's both because it gets under the, sorry, I'm going to try to speak U.S. terms that others will understand. So on the federal level, there's a credit, a renewable identification number credit that people get, but in California, there's a low carbon fuel credit. And between those two, the methane from anaerobic digestion is incredibly valuable. And it is something that we need to think about. The outside of those two types of things, of course, the liquid fuels become a much more valuable asset. And so this is not an either or kind of situation, though, in that we can make methane from the aqueous phase, as well as making a biocrude that can go into diesel and other fuels. And having that methane out of the aqueous phase becomes really a cost, I think, driver here.
Okay.
So
very interesting. Okay, well, thank you very much. I saw that all of a sudden the Q&A exploded, but I'm going to have to ask you to answer in writing, and then maybe we'll be able to come back to some of these questions, because now it's time for us to move on to the next half of this first part of session 2. So I'd like to introduce to you our next speaker, Erik Wormslev, from NIAS, a Danish consultancy engineering company. Erik, are you here? Yes, you are. I can hear you.
I'm here. Thank you very much, Lasse. Okay, and I hope you can see my screen now.
Yes.
Very good. Okay, so I'll have a few words regarding the end user perspectives and an outlook. And as to start with, I'm always looking into the broad perspective. We are facing a new era, and everybody knows about this, the circular economy, and we can see that we need a lot of new materials in our society. And I have been dealing a lot with aviation, and there is a huge demand for sustainable fuels for that sector. And if we can't provide it, I'm definitely sure that there will be some shame tax on that kind of transport in the future. But also chemicals. Dealing with plastics, we can see a huge demand, and it is increasing sector in the world, definitely because plastic is such a nice material. We can also see that there is some competitors in the market, as mentioned on my slide. And I think that Power-to-X, which has been introduced recently to this field, will play a major role, but we still have a lot of residues from urban areas and industry. So in that respect, I've been looking very much into what are we going to do with our wastewater sludge. Normally, or most frequent, we see that you're using an anaerobic digester, but there is a lot of loss of carbon in that process. We have some slaughterhouse waste. We have waste streams from the production of salmon, which is really a big issue in Norway, on the Faroe Island, and Iceland, and elsewhere. And we have got a lot of side streams from organic factories, all containing a lot of carbon, nutrients, and some even hazardous chemicals. If we're looking into the future, I can see some risks in use the digestate in farming. If that's suddenly being abandoned, then all the anaerobic digesters, they are facing a lot of problems. At present, I'm dealing with the pre-design of a huge wastewater treatment plant in Denmark, and we are looking very much into the alternatives, being anaerobic digestion, producing some methane and CO2. We can upgrade the CO2, we can turn the biogas to methanol, or we could take all the sludge, even the pre-sludge and the secondary sludge, and use the HTL process to create some crude oil. But in all these processes, economy are at the essence, and everybody is trying to find the most feasible and the best business case in that kind. And looking into, you can say, the overall perspectives, I would say that recovery of all the carbohydrates and nutrients in the most economical process will be one of the winners. And as I see it at present, the HTL process has the potential. But what I don't see yet is that we are facing a TRL level of, say, 7, 8 at present. We are looking very much forward to see the results of the demonstration facilities. But by the end of the day, it's economy and economy of scale that would lead us to the final clue. Although we, in many cases, will have incentives or gate fees on some of these resources, which might enable that to be one of the winners. So that was my point for this session. Thank you.
Thank you very much, Erik. That was very, very efficient and direct. So that was great. Thank you very much. We'll keep your questions coming in the feed, but we'll save the live part until the end of these 4 presentations. So let me now introduce our next speaker from Good Fuels in the Netherlands, Innovation Manager Johannes Schuurman.
Hello all, you can see me
Hi,
and hear me, I think. Hi, Lasse.
Yep.
Hi. Thank you everybody for this opportunity, and nice to see that there are over 200 people listening to this session. So my name is Johannes Schuurman, Innovation Manager of Good Fuels, mainly involved in the development of new marine biofuels. The organization only gives me 6 minutes, so let's get started with the presentation. Good Fuels. For the people who don't know Good Fuels, we are a sustainable biofuel supplier to the sectors that are hard to electrify. With those sectors, I mean, for example, the marine sector, the rail sector, and heavy road transport. The company was founded in 2015, and beginning of last year, we were, or Finco Fuel Group, a major Dutch downstream oil company, bought a majority share in our company. So we are young, but we are not that small anymore, and we have quite a big voice in the Dutch biofuel market, and especially in the shipping market. So why do we want to commercialize biofuels into the shipping sector? In this presentation, by the way, I will focus mainly on the shipping sector, because we think that HTL will first, has an opportunity in the shipping sector before, for example, in the sectors that need higher quality biofuels. So the shipping sector is a sector with quite much emissions. They have up to 3% of the global CO2 emissions. So why do we choose biofuels? As you all can imagine, these ships have very big engines. As you can see here, they need up to 100,000 horsepower for just one engine. And the lifetime of these ships are between 20 and 30 years. So all new vessels that are built now, they still have these diesel engines, and they require quite a lot of energy. So what do we need? We need a fuel with quite a high energy density, and that is still diesel. Because the current engines are diesel engines. So yeah, this is again a link to HTL, because HTL will probably produce a diesel fuel, and that can be used for at least the next 10 or 20 or 30 years into these ships. So the shipping industry is a conservative industry. No one, or not many companies, want to start with a new fuel first. So what did we do as Good Fuels? As Good Fuels, we started in 2015 with supplying HVO to the shipping sector. HVO, for the people who know HVO is hydrotreated vegetable oil. It's currently one of the best developed biofuels there is out there. You can see it on the left down side. It is a transparent fuel without almost no contaminations. But the downside of this fuel is that it's really expensive. So some customers wanted to use that fuel, but after a couple of times they stopped using it because it's just too expensive, especially for the seagoing vessels. And then in 2018, we developed the world's first biofuel oil, which you can see behind the text. This is more a blackish, intransparent, higher viscosity fuel. And we call it the Good Fuels MR100. And in 2018, we firstly supplied this to Northern and run a couple of tests. And nowadays, we actually supply it almost on a daily basis. It is a drop-in fuel. It works. We're currently doing all kinds of tests on board, see how the engine behaves, see how we can optimize the fuel, do emission tests, for example, to see whether NOx emissions will increase or decrease. So we are really in the development of this fuel. The only downside of this fuel is that it's made of liquid feedstocks, and liquid feedstocks, as you might know, are limited. So we need to find other conversion routes to scale up our supply. So how do we scale up? We are involved as Good Fuels in many Horizon 2020 projects. One of them is, for example, Next Gen Road Fuels, where we look into HTL. We don't only limit this to HTL, of course. We also look in other technologies like pyrolysis, sulfolysis. We don't limit ourselves to certain feedstocks, although we are very strict on sustainability requirements. But yeah, we don't see a silver bullet for just one feedstocks. So why are we interested in HTL? I think that HTL can meet the three pillars that are important for us for a marine biofuel, and that's that they can be sustainable, they can be scalable, and they can be affordable. Why sustainable? Yeah, you can use waste feedstocks. You don't have to use feedstocks that are edible for either humans or animals, for example. They are scalable. The big advantage of HCl is, of course, that you can use wet feedstocks compared to other conversion routes like pyrolysis, where you need dry feedstocks. You can also use solid feedstocks. Today, we can convert liquid feedstocks into liquid biofuels, but not solid feedstocks into solid or in liquid biofuels. So that's really an advantage. And the last thing is that we think that HCl can be affordable, or at least more affordable compared to the other advanced biofuels out there. The only technical question that remains is, what will be the quality of the end product? So for us as Good Fuels, it is really interesting to see whether it's possible to use the biocrude, the non-upgraded biocrude, already in a vessel. So we don't need in a vessel, we don't need the highest quality fuel. We need a fuel that's affordable for the vessel owners. And it would be really interesting to find out in the near future whether what level of upgrading is needed to make it sufficient for the marine sector. And I think that's where we're standing now, and that we need to find out soon. Thank you all. If you have any questions, please ask in the Q&A or send me an email. And
Thanks
I'll
a
come
lot,
back to you.
Yep. Thanks a lot, Johannes. Very nice. And I can confirm that there are already questions to you in the Q&A. So have a shot at that. Let me now then introduce the third speaker in this part, Marta Hugo from Concave. Marta, yeah, perfect. You need to just unmute.
Hi, hello everybody.
Perfect.
Just 1 second. Yeah, I'm trying to share my screen, but no, for what reason you cannot see it.
Yes, presentation mode, please.
Yeah, can you see it? Okay, sorry. Great. That's right. Okay, thank you. Thank you, everybody. It's a pleasure to be here. So actually, I'm representing Concave here. This is the European Refining Association. So actually the scientific part of the European Refining Association. And I would like just to give you a brief introduction on how we look at this HCl technology in Europe and within the work that we are doing in the association. So this is just a mention that we are currently representing like 41 member companies, so almost 100% of the European refining capacity in Europe. And our mission is just to develop scientific studies to support important decisions and relevant for climate. And one of the key questions that we asked ourselves a couple of years ago is like how to satisfy basically the need for the future need for fuels and the demand for our customers in a low GHG intensive manner, because in the refining sector, you know that we are not only producing fuels, we are also producing chemicals. And the idea is how we could just reduce our CO2 intensity, not only in the site, not only in the refinery, but also trying to minimize the CO2 intensity when the products, either fuels or chemicals, are used for the end users. And the way we found that this can be done is only through a multiple pathway strategies in a holistic way. So the first comment that I want to mention here is like there's no silver bullet, we have already mentioned, and we believe that we need a number of technologies, HCl being one of them, and we have to look at the whole picture. So what do we? So the vision for the association and the work that we have done in Concave is how these alternative feedstocks could be integrated within the refining scheme. And then we came up with this concept of the Vision 2050, where refinery is evolving or transforming itself. So it's not longer processing crude oil, but is integrating a number of alternative feedstocks, being either biofeedstocks, kind of biocrude, it could be waste materials, it could be CO2 to convert it into final products and fuels, as well as the integration of different low carbon technologies. So the point is how we could not only reduce the CO2 intensity here, but as mentioned, the carbon intensity of the final fuels for the customers. So we started in Concave looking at this transformation and actually modeling how this transformation could happen, and which technologies and which type of feedstocks could be integrating, replacing progressively oil from now until 2050. And this is about tackling the market uptake question. You know, what is the potential for alternative feedstocks in Europe and again today, but looking into 2050. The first, so we published the Refinery 2050 report, which is here and is available in our Concave website under the low carbon pathways part, if you want to have a look at it. But the first question is like, okay, demand for final products will be reduced, but the demand will still be significant towards 2050. Aviation and maritime is clear, partially road as well. If we want to replace oil by alternative feedstocks or low carbon intensity feedstocks, just one single type of material, type of feedstock or type of technology are not going to be able to satisfy the whole demand. Therefore, in our Refinery 2050 scenario, what we explore is the progressive different routes and the progressive integration of e-fuels, lipids, and building biomass waste technologies, and how these technologies could be integrating within the refining system, either through different routes. It could be hydrotreating, hydrocracking, or even rerouting part of that to the FCC units. For the woody and biomass, we saw and we identified pyrolysis and HCl as one of the technologies that we have explored here. So I think that this shows that this technology is becoming more relevant, and we are more and more interested in learning more and understanding the challenges for the integration of this technology within the system. When looking at the specifically on this type of feedstocks, one of the key questions that arises is, what about the value chains? What about the supply chain? Because the supply chain is not there. What about the centralized versus decentralized models? I think that some of them could be pre-processed in a kind of decentralized model closer to where the feedstocks are located, and then some pre-treated material coming into the refinery for the final adjustment or specification or treatment. But this, I would say, double side of the coin, decentralized versus centralized, are becoming more and more important. But also some other important aspect of these technologies is which is the electricity consumption that will be required and which is the hydrogen consumption that will be required. And especially when we are speaking about HCl, this is one of the areas that we should look at very carefully, and accessibility to low carbon hydrogen sources as well. Because again, if we are using the demand for hydrogen is expected to increase, when all those technologies are combined, our estimate is 2 to 5 times higher than the hydrogen consumption that the industry has today. And again, how to ensure that this is sustainable as well is a key factor. Very briefly, I will mention that all our assessments, so that was the analysis for the refining part. But of course, when this kind of biofuels are used, then we need to, again, minimize CO2 emissions time to wheels on the other side of the value chain. And that's what we are exploring in collaboration with UCAR and European Commission, JRC, in a number of studies that we have issued as part of the JEC well-to-wheel analysis. And the latest version was published end of last year, actually. And here, we are referring to HDL as one of the technologies, offering a compelling alternative in terms of energy efficiency as well, among different routes to produce synthetic diesel. So not just this technology, but you see that is interesting from the efficiency point of view, as well as from the GHG point of view. And then when we are looking at the whole picture, not only at the production side, but the well-to-wheel analysis, we can see that HCl routes being used in internal combustion engines offer a similar grams of CO2 equivalent per kilometer intensity as, for example, electric vehicles when the European mix is being used. Of course, I mean, you can have some variabilities, but it's showing the interest for the refining industry to go into this transformation and offering to the car manufacturers also a fuel that can actually compete in terms of well-to-wheel analysis and contribute as well to the low carbon mobility when, again, the well-to-wheel picture is taken into account. This is the last question. I think that you have my last slide, sorry. You have already mentioned the cost analysis. I think this is important. So we are looking at the cost implications and the ratio between the CO2 equivalent saved per megajoule versus the euro per ton of CO2 that can be saved for the production route. And still these synthetic fuels route are able to achieve significant CO2 savings, but still the cost is high. So I think that we should keep in mind this and work probably towards reducing these costs. Thank you.
Thank you very much, Marta. This was very interesting, very comprehensive. Maybe you could share a link to those publications in the chat now. I think that
absolutely
would be useful for a lot of us. Thanks a lot. The last speaker, and I might have messed up the who came before who, so I'm sorry about that, Sergios. But I would like now to introduce Sergios Karatsos, renewable feedstock coordinator from the Parkland Refining Company in Canada. So a refiner who's actually engaging in this. Sergios, floor is yours.
Thanks, Silas. Appreciate the opportunity to share some thoughts in this forum. Obviously, I'm no stranger to the Next Gen Road Fuels program. I worked in it before I moved to work with Parkland. As refiners, we have a key role to play in the commercialization of biocrudes, and that's because we are, number one, obligated to reduce emissions of the fuels that we sell, and number two, because we are the gateway to the path to market for a lot of these biocrudes. And the best way to do this is by leveraging the existing $1 trillion petroleum infrastructure in the world and to co-process these biocrudes in existing refinery assets. And meanwhile, also leveraging the know-how of decades that these refiners have accumulated in troubleshooting different challenging feedstocks. So Parkland is a leader in Canada and globally in those co-processing areas. And our refinery in Burnaby, British Columbia, has been under low carbon fuel regulations since 2013. And that has obviously spurred a lot of innovation and culture change in our refinery. And we started co-processing trials in 2017. And today we are commercially at large scale co-processing vegetable oils and animal fats. In fact, in 2019, we co-processed enough vegetable oils and animal fats to take the equivalent of 15,000 cars off the road in terms of emissions. And in 2020, we tripled that figure to 45,000 cars. And we keep on trailblazing and really going very aggressive in this space and growing. And while we do this, of course, we look at diversification of feedstocks. And we look at the emerging feedstocks. A big part of what I do in the refinery is looking for these new feedstocks and evaluating them for co-processing. And of course, HTL biocrude is no exception to this endeavor, and quite a promising one at that. And based on my experience, I just wanted to share a couple of highlights that I think are important for refiners to accept and be comfortable with signing offtakes for biocrudes. And I'd like to keep it very simple in three main areas: quality, volume, and time. These are the three main components that we need in simple terms. So in terms of quality, obviously, we look at the characteristics of the biocrude and we identify if we can really make value out of that biocrude, and if we can, where is it best to integrate it in the refinery, whether it's the hydrotreater or the cracker. the FCC, and so on. And obviously the FCC has many advantages in this space because it can tolerate a lot of inferior quality liquids and a lot of contaminants. So there is definitely an opportunity to mitigate some of the costs that are associated with taking those biocrudes into great upgrading extents. One aspect of quality that I'd really like to emphasize and often gets overlooked is the handling and storage. The refinery can do a lot to fine-tune the process of the FCC or other unit to tolerate some quality issues, but it cannot do very much if that biocrude cannot even get to those refinery units. So how this biocrude will store, what's the aging and reactivity aspects of that biocrude, the pumpability, the viscosity, polymerization propensity, odors and vapors are all things that often get overlooked in these relationships and are very important for us to get comfort around how we'll bring that biocrude into the refinery. And the final item of quality, of course, is the carbon intensity, which is what it's all about. And one thing about carbon intensity that's really important is that it's very specific to each refinery. So depending on the location of the refinery, depending on the setup of the refinery, and even the type of carbon accounting that happens in the specific regulations in that jurisdiction, the value will change and how the refinery can make value out of the certain product and the carbon intensity changes. So very, very, very project specific is what I'm trying to emphasize here for the value of these biocrudes. And of course, all of the quality also affects the kind of yield we can get and the kind of product we can get. So moving on to volume. Volume has two aspects for us. We have to have a line of sight to enough volume for sampling and to enough volume for scale-up tests, followed by refinery tests. At the same time, we have to have a line of sight to commercial volumes. It's very difficult for us to make a business case internally if we can't point to commercial volumes at the relevant location to our refinery. And we're, contrary to perception, we don't necessarily need huge amounts of volume, but enough to make a business case and enough to show a margin. And whenever we look at facilities that are relevant to our location, we look at the schedule, we look at the partners, the financing, and obviously where it makes sense, we're willing to play our part in this endeavor. The final item is time. And refiners need time, and that's obviously a problem for many developers. The reason refiners need time is because refineries have lengthy internal processes for accepting new feedstocks. And that's because of the nature of the industry, and that's also because of how expensive and sensitive refinery assets are. Advanced feedstocks are very different to what we're used to. Not personally me, because I've worked with biocrudes for a while, but the refinery is not used to them. And so it takes time to build that internal buy-in, and it takes time to build that education component for everyone to understand the nuances of these new feedstocks, and especially the aspects of oxygen content that completely changes how the properties can be interpreted. I'd like to close by saying that one item that's not necessarily important, and a lot of people think it is, which is we don't expect biocrudes to be completely hydrocarbon-like. We are prepared to do our part, at least as Parkland we are. Maybe others aren't, but we are definitely prepared to do our part, and we're already gearing up to do our part in terms of improved handling capabilities and in terms of what we can do to reduce the amount of upgrading that's needed on the other side of the fence. And that's a perfect segue to my closing comment, which is as we continue to de-risk the quality, the volume and the time aspects of these new biocrudes, we are open to collaborations, and we can't do it alone. So please reach out. I hand it back to Lasse. Thanks.
Thank you very much, Sergios, for this insight into what it looks like when refiners sort of gaze into this area. Thanks a lot. I've been keeping an eye on the Q&A, and it's been extremely active. Lots of people asking, and the panelists are answering. So I think we will keep that boiling. So keep writing in there, and the panelists, please keep answering. Because in the interest of time, I think it is now we're at the point where we should hand over to the panel discussion. So I would like to invite the moderator, Dina Barkowski, here you are, welcome, as well as the panelists to turn on their cameras, and then I hand over to Dina.
Thank you very much, Lasse, for this introduction and for handing over at this point. So it's my pleasure to be here with this workshop today. And actually, I am working with a company based in Austria, Bioenergy and Sustainable Technologies. But I'm here today in my function as leader of the working group 2 on conversion processes of the ETIP bioenergy. And just for those who are not aware of it, this is the European technology and innovation platform that deals with biofuels and bioenergy. And we want to bring together the industry and the academia in this space, and we want to discuss R&D priorities and share information. And we have a lot of ongoing activities, and several of these are done by working groups. And so one of these working groups is the one on conversion processes, and we have started last year a webinar series to exchange information on various technologies. HDL will for sure be one on the list for this year, but at the moment I'm very happy to be involved in this workshop because I think it brings together much expertise, and I'm happy to chair a panel discussion here to discuss some or gain some insights with the panelists. So I think everybody is online, all of the panelists. So I would like to start with a question about what do you see as the advantage of HTL technology over other advanced biofuels technologies? And I don't know who wants to start on this. Maybe Perry, Steeper Energy.
Yeah, perhaps I've got a vested interest in a positive and enthusiastic response to this. HTL, of course, is a technology that I myself came to know about only about 20 years ago, and it was as a part of a very large search into techno-economic analysis of different thermochemical pathways to biofuels. So while biofuels have been talked about in my entire career, which I won't get into exactly how many decades that is, but it's many, many decades in the energy industry, we've talked about biomass as a bit of aspirationally, it's been talked about for a long, long time for both solid and liquid fuels. And liquid fuels for the last 10, 15 years, it's really been a terrifically important area. We saw some early activities in the early 2000s, predominantly around pyrolysis, which had been talked about since the 1980s, and in fact the 1970s in the first oil crises. HTL really attracted me, and I think it continues to be attractive to the industry because it ultimately is it's a low input play. In other words, the amount of energy that you have to put into the system to get out a relatively low oxygenated biocrude is quite exciting. And Steeper has really advanced a lot of the balance of plant issues around HTL. So in the general public, HTL is kind of considered magic. What you put woody waste or biogenic waste into one end of a high pressure system, and out comes this black petroleum-esque or smelling oil. Isn't that magical? But of course, we've actually spent the last 10 years worried about How do you manage the front end? How do you manage feedstock delivery, hydric matter content slurries, separating the products of HTL, water, gas, oil, of course, ash, and separating the commingled materials? And finally, in the last few years, we've focused a lot on the upgrading of HTL oils to finished fuels, and so much so, as we've heard from my colleagues, we've actually built a petroleum lab dedicated to both co-processing of HTL oils with petroleum equivalent feedstocks, petroleum feedstocks, as well as going directly from HTL biocrudes to finished fuels. HTL, by delivering a low oxygenated, high carbon, high energy and density liquid, really gets as close as we can from biogenic materials to petroleum or fossil equivalent materials. And I think that, plus the fact that in Steeper, we've shown techno-economic analysis that suggests that you can cost effectively produce biocrudes in and around the $40 to $50 US a barrel range in the nth plant, opens up the possibilities that while it will always be more expensive than fossil crude, and let me be very clear about this, and in every presentation I say this, we are not chasing a snowball downhill. Fossil crude will continue to get cheaper and cheaper until you get to the lowest common denominator of production. HTL biocrudes will be cost effective for a modern society to afford, and it has the best potential of decarbonization, especially of the internal combustion engines that will continue to use diesel and kerosene derivative fuels. So I think all those things, technical, business, and indeed the introduction of the technology integrated into what Sergio has rightly said, the trillions of dollars of enduring petroleum infrastructure, makes HTL really the killer app, as it were, for the transition economy. That is the economy for the next 50, 70 years before we come up with some very clever new propulsion systems.
Thank you, Perry. Thank you. So I wonder what others would like to say to this, what the advantage of the HTL fuel is. Yeah, Eric, just a minute. And John, your camera is not on, but would you be with us as well? Let's turn to Eric first, because he's already raised his hand.
I have a few comments. I would say that the carbon reuse is at the essence. Then the decomposition of many art materials in the same process is an advantage. The temperature is an advantage because we will have hygienization of the material that we put into it. A lot of material contains microbes of different kinds, and in order to treat it in the most appropriate way, we have to make a hygienization at the same time. We have recently seen in our society that we have got rid of all our mink. We have killed more than 1 billion mink in Denmark recently due to corona, and if we had had such a plant, we would easily have made a liquefaction of all the dead animals and pumped it through such a vessel in order to regain at least some value of these bad animals. And then, of course, I see that all the wet material, all the residues, and the potential of getting a gate feed. So if we compare this to anaerobic digestion in the wastewater treatment, and that we can get some water fraction out of it, which is as less contaminant as possible, I think that there is a potential for the HTL process to be very interesting in a comparison with the anaerobic digestion. My comment.
Thank you very much, Eric. Thank you. And so, John, now your camera is on. You ready to comment on that as well?
Sure. Let me give you 4 quick things. I think Perry spoke about these to some degree, but let me just reiterate them. The first is yield. The HTL process provides the highest yield to a fuel of any process that we have studied, and that's incredibly important. The second is the biocrude oil is stable. So many of the thermal processes do not make a stable oil. Having a stable oil is incredibly important and greatly reduces cost and challenges later. The third, I think Eric kind of talked about already, and that's some of the water management and particularly removing some things that we really don't want in water that wastewater treatment plants and other things have a difficult time doing. And then let me see, I had a fourth one as well, and it's kind of skipped my mind, but there are a number of these kinds of advantages, starting from yield, going down, I guess the fourth one would be versus AD, and AD is a really important technology, is that with HTL, we can really reduce the amount of sludges that some of the other processes are not able to reduce. So thank you.
Thank you, John. Thanks a lot. Good. So then let's turn to another question about the most critical issues that we would see along the supply chain. So again, turning to Perry Thoms first. Do you find it hard to find buyers for your product or investors for the production facilities? And what kind of concerns do you hear most frequently?
Well, a nod to Stephen Gust, who's been active on the panel, asking a lot of questions about the practical applications of the technology. What we find right now is that the TRL levels are near commercialization, and we spent many years of our first 10 years of our life looking for strategic partners to co-develop large enough scale demonstrations to give confidence to the marketplace. We suffered deeply from the fact that pyrolysis, or the word pyrolysis, has been in the common lexicon for decades and decades. And so there's a false view that there's no technology risk in pyrolysis. So let's focus on all the other difficulties about pyrolytic oils, because at least the core technology is like falling off a bicycle. And of course, that is not true. Likewise, there's a falsetto out there that, for instance, other technologies, again, I'll use pyrolysis as a poster child, or gasification, are more cost effective. In other words, the capital costs are lower per unit production, so you can get away with having more hassle on the upgrading end. Again, not true. The pots and pans for most thermal conversion technologies, in fact, in any industry, whether it's the bio or indeed the thermochemical conversion of petroleum products, are about the same per unit barrel of equivalent energy out, or bio crude in our particular case. So what we have is a lot of misconception out there, a lot of conservatism. Steeper is focused in two major areas: paid for waste destruction, but also in the conversion of large scale biomass from forestry and agricultural residues. We see early wins are going to come in the large scale conversion of biogenic waste from forestry and agriculture, where you're talking about minimum scale plants of about 2,000 barrels per day, probably maxing out at something around 10,000 barrels per day. But even at 2,000 barrels per day, you're talking about approximately 250 million euro for that first commercial plant. And the question mark is, do you rely on one player in the forestry industry, or one refiner like Parkland or Suncor or Shell or BP or whomever to make that play? And then if you say, well, there's a greater societal benefit here, which has been well outlined by John and others in the public domain, then what role do governments and policymakers play in adopting or recognizing or proliferating this technology, and to what end? Who's the beneficiaries? It's a very complex issue, and I think infrastructure is particularly struggles with new innovative technologies. Quite frankly, we have solved much more complicated problems than both expanding the use of HTL in the generation of liquid fuels, and in solving the in situ issues within HTL production. I'll make one last quick comment. One of the largest industries in Canada, in fact, the largest export industry in Canada, is petroleum products derived oil sands, or you call them in Europe tar sands. These materials were known for hundreds of years to be available, and it's about the third largest repository of petroleum in the world. And yet they are notoriously difficult to extract. But today, Canada produces something in the order of 4 million barrels per day of fuel from those materials. I can guarantee you that HTL and the conversion of large-scale biogenic materials, be it waste products from forestry or energy cropping technologies that
it's 9 o'clock.
That will undoubtedly appear in the next little while, are a lot less complicated than what was required there. And yet society, Canadian society particularly, but North American society, decided that repository of hydrocarbons were so important, they were prepared to take those risks and make those things happen. And I'm just not sure in today's world, in the 21st century, how you get that same kind of national or international support for risk taking that we have seen in other infrastructure and energy projects in the past, and we struggle on with that and continue to look for brave partners and investors to join us on that journey. But I can say all this, and I think most of the players on this panel would agree. This is not rocket surgery, to use a colloquium.
Can I chime in on this for a second?
Please. The next question was going to go to you anyways, because
okay. Okay.
Would you take in the oil?
Yeah. Well, perfect. So so that's exactly what I was going to talk about. So yeah, I think that everything Perry just shared is true, and I lived it by working with him for a while. So I definitely resonate with what he just said. But I also want to emphasize that I truly think that path to market is really the key in this process of commercialization, and not only because we are involved in this and we are living it every day, but also because once you have the path to market, everything else, in my mind, will fall into place. Everybody wants a success. And if they can point to a success, if politicians can point to success, if bureaucrats can point to success, if investors can point to success, and by point to success, I mean, who will buy it and who is closer to buying it and at a good value so they can pay something reasonable for it, right? So I think policies want a success, investors want a success, academia wants to continue contributing to success. So if there's a path to market established, everything else will fall into place. And that's no easy feat. That's what we're involved in, and it's actually quite challenging. So, and it takes time. So that's my 2 cents.
Thank you, Sergius. And so then let's turn one step further in the supply chain. Good Fuels would probably be the one buying a product that was produced via HTL and then probably upgraded or not so much upgraded to be used as a marine fuel. So actually, what are your requirements that you would pose on the biofuel batches in order to accept them? And does the HTL fit into this?
Okay, yeah, whether HTL will fit or not, we don't know yet. But for comparison, the fuel that ships are using currently, that has always been the bottom of the barrel. So really blackish, heavy fuel with a lot of contaminants in it. And that's where you need to compete with. So during my presentation, I told you already that we are supplying this biofuel oil, and that is also not the cleanest fuel. There's still some oxygen in it, still some contaminants in it, but it works. And the engine makers of these vessels and the fuel system makers of these vessels, they have designed a system on board of the ship that a fuel can be cleaned. So the fuel can be heated, goes to a couple of filters, separators to centrifuge out the heavy parts. And then the engines are quite massive and can handle quite a broad range of fuels, which makes it interesting for a new fuel that comes on the market and does not has to be perfect at the beginning. So what needs to be the quality of this fuel? There's no standard to meet. No standard for a biofuel. For HVO, for example, you have a standard. For FAME, you do have this standard, but for marine fuels, you don't have a standard. You only have a fossil standard. Just the first starting point would be to meet at least the fossil standard. And there are some parameters in there that does not make sense for biofuels. But if you can meet the most important parameters of that standard, then you probably may succeed in commercializing this fuel as a marine fuel.
Thank you, Johannes. So then let's take a look from more above. We have biomass, which we need to convert via HTL and probably upgrade that biocrude in a refinery. And then we have the refinery is a very huge operation. So we have very large volumes there. How can we match the scales? I mean, to get a meaningful bio content into something as big as a refinery. And I have several here who I would like to pose this question to, but I would again start with Perry as the technology developer. So how do you see that you can match the scales of the biomass intake and what you need to provide to the refinery?
Yeah, thank you. It's certainly one of the things that we heard a lot in the early days of Steeper from the petroleum industry when they bothered to talk to us at all was, you know, if you can't provide something in the order of 50,000 barrels per day, please don't bother knocking again. There are opportunities to aggregate biomass in a regional setting. I think that the missing piece is folks from the traditional or conventional energy industry like to see all their infrastructure in one place. Trillions of dollars of infrastructure in a relatively small geography seems to make sense. Whereas in the biofuel sector generally, in HTL specifically, a hub and spoke play will be critical. That is, upgrading may only happen, and whether that is in fact a direct upgrading of hydrofraction oil, or in our case, hydrofraction oil, HCl oils, directly to finished drop-in fuels, or indeed to supply co-processing, you're talking about 3, 4, 6, 10 plants aggregating something in the order of 10 to 20 to 30,000 barrels per day, and then having that upgraded at a single location. Again, Steeper is doing a lot of work on both co-processing and direct processing of biofuels. I would say that we have an internal view that probably as little as 10,000 barrels per day could be aggregated for a direct conversion into drop-in fuels at a fairly cost-effective basis. That having been said, you know, sort of just brought to our attention the issue of refiners' comfort level at the operations level, how much and at what level. Some refiners are pursuing the FCC as the entry point for biofuels. I think that works for lower quality biofuels, where you're providing a lot of thermal energy in the system, but not so much biogenic carbon in the finished fuels. HTL, and specifically Steeper, we have a deep philosophy that the fuel should skip the FCC and go to the hydrotreater unit, whatever configuration that a particular refiner has, to maximize the amount of biogenic material in the finished fuels. And we do a lot of work here at Steeper to show that pathway. So again, getting up to 20% or more is our goal in terms of the amount of biofuel as a function of the total amount of heavy fuel going to the hydrocracker. So these are all areas that I think that need to be explored. It's aggregating biomass for 2,000 to 6,000 barrel per day plays, aggregating biofuels from a variety of regional centers into centralized upgrading facilities, and then pushing the envelope in terms of where it the biocrude enters the refinery, and how do we maximize the amount of biogenic material or carbon-14 material in the finished fuels.
Thank you, Perry. And Sergius, would you like to add to that?
Yeah, I don't necessarily see the need to meet the scale of refiners in the sense that, yes, you know, hundreds of thousands of barrels is the scale at which refineries are typically operating. And to Perry's point, the capital assets are aggregated. But I'm of the view, and I think our organization at large is of the view that we have to start step by step, and that you know, small volumes in the first instance, if they can be made. I mean, I think the challenge is the smaller the facility, the economies of scale diminish. But if they can be made economically at small scale, you know, our appetite is little by little, I would say.
Oh, that's great, because of course it takes time to build an industry. So,
if I may, Dina, if I may.
Yes, please,
very
Marta.
quickly. Yeah,
Please.
because I think I tend to agree with everything that has been said. So I think we are in the middle of a kind of transition. And as a transition, we need to start with low volumes. So I think that we cannot just try to get to the maximum right now, and we need to try to start testing these fuels, the different routes in the refineries, and each of the refineries will choose the best route for them. Either it's going to be an FCC, hydrocracking, or hydrotreating. It will depend on how each specific refinery see their transition, also depending on the regional circumstances as well. I think that is important to keep in mind that for me, there's no single, again, type of feedstock or type of technology. So we will need to, at the end of this transition, we need to probably replace oil by big quantities, but it will not be just one single technology. And if we aim to reach this level of volumes, then probably we will fail, because we will never start. So the thing is, like, let's kick it off. Let's try to starting the pilot plants and the demo plants and getting into the first industrial commercial scales. But industrial for these specific technologies doesn't need to be big scale similar to refineries. I do really like the flexibility that the HTL gives in terms of decentralizing places and then rerouting some kind of pre-processed biocrude into the refineries, into centralized sites. I think it gives a lot of flexibility. It allows for the refinery to integrate bio components no matter where they are, and I think this is really important. So it's not just because in a really short radio distance they have the feedstock available. It allows to expand the distance towards the feedstock is, and I think that it will be really key in the future. So I think that's what I wanted to say.
Thanks a lot, Marta. So again, it's this decentralized approach that will make it happen. And now I wonder, like, Johannes, if we turn to good fuels, you probably get less upgraded fuel batches, maybe from standalone facilities and not from the refineries, but you have, again, huge volume demands from the ships.
Yes,
how will you match that?
There are huge volume demands, of course, but we can start with a small trial. And we don't have to start with a 100% HTL fuel. We also can start with a 10% blend, for example, and see how the fuel then behaves in an engine, and then slowly scale up to a higher percentage, and finally to a pure HTL oil, of course. But this only makes sense when there's an outlook for higher volumes. So we can start small. We don't need as much volumes as the Shells and the BPs of this world. But we need an outlook that at least our investments will lead to to bigger volumes in the future.
Sure, thank you. Good. So since we have an international panel here, and not only from Europe but also from overseas, does anyone see regional differences in the opportunities and the challenges for HTL technologies? So I'm looking on Sergius or John or Eric to comment on this. John, please go ahead.
Yeah, so even within the United States, even within North America, there are regional differences, and I think it's important that we understand that. I think all biofuels are regional, and we need to be able to. So one of the values of HTL is it's able to take such a diversity of feedstocks, and I alluded to in my talk the importance of even considering blends. We think within a 50-mile radius that might be appropriate for collecting a wet feedstock. We're not going to be able to have a single feedstock, and that oftentimes we will need blended feedstocks, and those blends will look different depending upon whether I'm in a rural region or if I'm in an urban region, if I'm near a place where there could be marine sources as well, and so dramatic differences, and understanding what does the biocrude look like from these different feedstocks is important, as well as are there unique challenges in the upgrading step based on these feedstock blends.
So you're actually saying that the differences within Europe are as large as the differences between Europe and North America, or the differences within North America are as large as if you go from one continent to the other?
I think so, and in some cases, the commonality, there might be more commonality within a urban setting in Europe and an urban setting in North America, and a rural setting in Europe and a rural setting in North America.
Sure, thank you. Sergius, do you want to comment?
Yeah, just quickly, I think just to give a little bit of the other side of the fence on the end use side, I think that can also be very regionally diverse, and I think we see that with regulatory landscapes. We see that with different setups of supply chains, and we see that with different end user setups as well. I mean, I can certainly speak to the fact which I alluded to in my talk, which is the diversity of how different refiners are to each other, how different refineries are to each other, and how different regulatory landscapes can be, and how that comes together to construct the value that an end user can look to. So definitely tremendous regional differences, I would say, in terms of and you could argue that that may cause some arbitrage for some traders, but certainly that's the case.
Thank you. And then Eric, please.
Yeah, I can only add two things. Recently, we have seen that the Shell refinery in Denmark has been taken over by a group of investors who will turn that refinery to be green in the future. So that could lead to a business opportunity in this region. And then I would like to add that I think that the key game changer will be taxes on the black carbon. And we have recently seen that the Norwegians, they have launched that by 2030, they will have a taxation on the black carbon in the magnitude of 200 euros per ton of CO2. And I think that it is that kind of legislation that would lead us into all these possibilities quicker than ever before.
Thank you very much, Eric. Nice statement. So looking at the watch, we have about 10 more minutes to go with the panel discussion at maximum, and I do have a few more questions. So now let's go for very precise or concise statements, very brief statements. So if we come to prospects for HTL, what do you think is needed most now? Is it R&D? Is it demonstration, or is it creating the market through the right policies? And I'm just going to ask this question to two people. So I'd like to start with Good Fuels, with Johannes.
Yes, thank you. I would say demonstration is the most important point now. So it is for the technology developers quite hard to finance these demonstration plans, because they need to find off-takers, they need to find investors, and exactly as Perry said before, maybe a government should take a role in this. Why shouldn't they invest in demonstration plans and take the risk so that the the typical valley of death, when high investments are needed, can finally be covered, and that we can move forward, because a lot of R&D work is already done and subsidized by the European Commission, for example. But to find financing for these demonstration plants, that's quite a hard point. So I would focus on that.
Thank you, Johannes. And so the second one here, Perry, probably you, but a very brief statement, please.
Yeah, it's money. That is the critical next step. Even demonstration needs to go to the most viable scale commercial projects.
Okay, thank you. So there's agreement here. So what do you see as the necessary next steps to implement biofuels based on HTL technologies? Anybody willing to answer to that question with a brief statement?
It's got to be regulation. Biofuels cannot compete with fossil if it's just on a price basis. The only way to equalize it is either to give a price for carbon, or indeed articulate that biofuels have to make up a certain percentage of the fuel base. No matter what it's a regulatory framework. All of society's energy needs are focused on regulation. This is no different.
I can see Eric nodding and raising his hand. Please go ahead.
Yeah, I can add to what Perry says, that I fully agree. But on the other hand, being a consultant, I cannot deal with any of our clients before this has reached into a TRL between 8 and 9 level. So in that respect, I fully agree. We need a full demonstration before we can start discussing real opportunities for a commercialization of it. And that should be supported by either some incentives or by a black carbon tax.
Thank you. Marta, please go ahead.
Yes, Tina, I would like just to complement, because I think I would like to add the cross-sectorial cooperation to this picture. I think this is essential, because when you are speaking about a demo plant, it's not only about the technology as a standalone unit. So you need to ensure that the whole value chain, so from the feedstock, how you mobilize the feedstock, how you transport it, how you transform it, then how you transport and handle and storage the intermediate product, how you process it in the big centralized or refineries or whatever. So the whole demo project involves the whole value chain, and there are so many key players that we need cross-sectorial cooperation. I mean, for me, it's a must. It's not about just one single player here alone. It's just about making this happen, any technology happen, I mean, all together. So I think that's important on top of the policy. And
thank you, Marta. This is so good to hear. I mean, the biofuels industry has trying to bring the biofuels to the market, and it has taken a long time for the refineries to come on board. And it's very good to hear now that the refinery people are saying, yeah, we need to collaborate on this. So I will allow Sergius to make a point here. And I don't know whether Johannes wanted to add something as well, because you're unmuted, and that's why I was thinking you might want to say something. No, so please, Sergius, make a brief statement.
Very brief, yeah. Just to say that I very much echo everybody's emphasis on demonstration and on government's role in supporting that demonstration, and also excellent point from Marta in terms of the extending that demonstration not just on the process, conversion process itself, but all the way along the supply chain and the transport routes and the storage routes. And what with that will also come in hand in hand with demonstrating the market for these products. Because, for example, if I see from our perspective, I spoke about volume for trials, right? So trials in the refinery are not a couple of liters, right? They are hundreds of barrels. So having that demonstration capacity to even pile up those volumes over time, they don't have to be produced in one day, and then ship them over to the refinery through a demonstrated supply chain, and then the refinery can trial them out and build confidence into the internal operations. That will work for us too.
Thank you very much. So we've heard a lot about important factors and critical issues here. So I think we have to very soon hand back to Lasse for closing the workshop. So when you look back at the workshop that you've witnessed today, could you come up with one key message or takeaway message, either one that you've learned today or something that from your own experience you think is very important for all the other participants here? So just one takeaway message from each of you, and I don't know who would like to start on this.
I'll share something very quick. I see from this workshop, and just from pretty much my entire career, I see a lot of this happening. So broadening out, because everybody's hedging their bets. So the refiners are hedging their bets because they're trying to work with as many companies as possible, so that if a lot of them fail, one will succeed. And investors are doing the same thing, and startups are doing the same thing. They're working with multiple potential strategic partners because somebody might bail out on them. But just listening to everyone today, I almost feel like we have to start doing a little bit of this, and we have to start focusing a little bit more into developing one specific or two or three specific supply chains and demonstrating them and kind of getting that commitment. That commitment can only come if again, what we said earlier, the government steps up and supports that specific supply chain demonstration. At least that way, everybody can point to one success, and that one success can seed a lot of deployment in the industry. So that's my takeaway.
Thank you. Who's next?
Well, my
John?
2 cents worth is potentially about collaboration. I think we are on the edge of forming an industry. So we talk a lot about it being on the edge of commercialization of our individual technologies, and we have created a number of innovations across the board. But HTL and all the players that are in HTL actually represent a very interesting opportunity for collaboration, cooperation, and the creation of an HTL industry. Just like every other industry that is out there, you compete on the basis that your unique offering will work in a particular situation, perhaps better than some of your compatriots. But as a group, you compete against misinformation or misunderstanding in the marketplace. You compete against the fossil world. You compete against other forms of low energy density fuels that are being purported for the light duty fleets and so on. I think that we're going to have to start to put some effort into working together on certain things, including government policy and so on, and advocacy.
Thank you. John?
So really quickly, I'm going to just use a keyword that Marta said, integration. Integration across the value chain and integration across the technology, so that all those steps are fully done. And across that value chain, this would end with understanding the fuel quality. And so that integration from starting at the beginning of the value chain to the end. Thank you.
Yeah, I will follow up on that. The fuel quality is for us also the most important factor. We are ready to commercialize a product, but we need to know the quality, and the quality should be consistent. But when it is, we are ready to commercialize it.
Thank you. Marta?
So just echoing everything that has been said. So for me, these are like the key messages, this supply chain demo and going up to the final use. So actually it's not only the fuel quality, but also the engine manufacturer trying to understand the implications there. So dreaming of this kind of big demo project from side to side would be like the ideal. And I think that we are almost there. So I think that that's what I can see, not that we are like approaching this point where the key actors are willing somehow to take part of this. So with the support, we need some support at national level and at policy level, and that's the key probably factor to make this happen. But the willingness is there, so that's my takeaway.
Perfect, thank you, Marta. So Eric.
Yeah, my takeaway is that I'm quite optimistic following the sessions today. It seems that we are in progress, and we are soon there where we have a full demonstration facility, and I would then soon have all the data I need to make some feasibility analysis regarding various streams that I'm taking care of in my daily life, and to see whether the HTL process is more profitable than others. And that's what I'm looking forward to. Thank you very much.
Thank you, Eric. So then thank you to all the panelists for this excellent discussion. Thank you for the audience who has still kept listening to us. And I hand back to Lasse Rosendahl.
Microphone, please.
Sorry, it was up. Sorry about that. So let me just repeat. Thank you, Dina, for hosting and chairing the panel. It's been very, very interesting. And thank you also to the panelists for really sharing some insights and some very good points. I think I would let the final comments or the final remarks of the panel stand as the sort of the closing, and just say that I think this has been a hugely successful workshop. I think it's very, very good that we come together and we discuss and share. And I can also see from the Q&A that individual private conversations have developed, and I think that is absolutely great that we're doing this. As I think Perry was saying, you know, it's really important that we are also perceive ourselves as a community who are trying to carve out a space for ourselves in the world. So thanks to everyone, also all the attendees. I think, I don't know if someone from the ETA Florence team might just repeat how this workshop will be made available to everyone afterwards.
Yes, Lasse, this is Chiara. So the presentations and recording will be available from tomorrow on Next Gen Road Fuels project. So stay tuned and yeah, check it out tomorrow.
Perfect. Okay. So thank you very much, everyone. We need to do this again soon. So thanks everybody for joining.
Thank you.